Welcome back. In this video, we will take a look at the Profiles YAML file and define an ID stitcher model, which will produce an ID graph within our target schema after a run. For a freshly initialized project, you will have more example code in this file. Much like the inputs file, we can use the structure here for reference and modify it as necessary. For now, we are only going to define the ID stitcher model, so we can comment out the variable groups key and everything nested underneath. We will come back to that in a subsequent video. Let's modify the ID stitcher model so that we can produce an ID graph. I'm going to name this Secure Solutions User Profile. The name you define here will be the name of the ID graph materialized in your warehouse after a run. We will then link this model to our user entity. It is worth noting, the ID graph will build incrementally by default. I am going to add a run type configuration here and input discrete. This will force the graph to do a full rebuild on each run. Because we have yet to QA the outputs, we want to make sure to perform a full rebuild on each run so that we can QA the outputs of some of the underlying base tables as well as the final ID graph. Once we have verified the accuracy of the ID graph, we will change the run type to incremental so that we are not performing a full rebuild on each run. Once the ID stitcher is set to incremental, it will build incrementally by using the timestamp columns you defined within your input definitions, which will drastically reduce the processing time. Another thing I want to note here is the environment changes that could trigger another full rebuild. If any of the ID stitcher's dependencies are updated, such as an input definition that feeds the ID stitcher, this will trigger a full rebuild. A full rebuild is also triggered if you modify any ID type filters or if you upgrade profiles and migrate the YAML schema version. The final step for the model configuration is to define the edge sources we want to use for the stitcher. This is telling profiles exactly what inputs or models you want involved within the stitching process. You may have 20 inputs, but only need 10 inputs in order to build your ID graph. Here are the inputs that Secure Solutions needs in order to build their ID graph. To recap our progress thus far, we have now defined an entity, the associated ID types, defined our inputs, and finally, an ID stitcher model. We are now ready for our first run. But first, this is a great time to save our project. As mentioned in a previous video, saving in this context means saving this configuration within this session. We can then run this configuration or return to the same session later if desired. Additionally, we can commit these changes. Committing here will commit this configuration to your production project. And if your production project is connected to a cloud repo, it will commit the changes there as well. Okay, let's run this project. As explained before, when Profiles runs, it will compile all of your YAML configuration files, construct a dependency graph, generate SQL, and deploy that SQL in the order of the dependency graph. The run is now complete. Before we query the outputs, let's review the behavior of a Profiles run. Each Profiles run will create artifacts associated with that run. If you are developing locally, you will notice that an additional directory called output is created within your project when you trigger a run. If you open up this directory, you will see a new subdirectory populated for each run. If I open up this subdirectory, we will see two additional subdirectories, compile and run. The compile directory will contain all of the generated SQL based on your configuration for each run. The run directory will contain all the generated SQL that was successfully deployed to your warehouse for each run. If all was successful, these two directories should match. Within the IDE, you will also see a log file beneath the sequence number directory. This will contain all the program logs. Any interruptions or errors associated to a run will be logged here. So in the event that happens, we can read the specific errors and address them accordingly. Let's take a look at the run artifacts for reference. Once the run is completed or the run was stopped due to an error, you will see a drop-down arrow that you can click for a specific run. This mimics the output directory if developing locally. Here, you will see the log file for that specific run, and you will see the sequence number directory and the associated compile and run directories mentioned above. Great. In the next video, we will observe the outputs from this run.